Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's my great pleasure today to introduce Anita Sarma, who's visiting us from UC Irvine. She is wrapping up her PhD, which is why she's smiling, and hitting the job market soon. So she's here to give us sort of a sneak peek at her job talk. She's going to tell us about a system called Palantir that she's been working on for team awareness on software development teams, helping teams coordinate. So thanks.
Okay. Thank you, Rob. So I'm going to be talking about how can we bridge the formal and the informal approaches to coordination. Let me start. So let me give a little background about what software development is. As we all know, it's a group effort. In a typical scenario, you would have two developers, say Ellen and Pete, working together in a project. They would have a configuration management repository that they can check out the artifacts, and they work on their own. Let's assume a scenario where both Ellen and Pete are working in their workspaces and they change the same file inadvertently. What will happen in a CM system is the developer who finishes their changes first and checks in the artifact would be going scot-free. They'll have no problems. But let's assume that Pete is the person who finishes his changes second and tries to check in. The CM system will not let him do that because there will be a conflict. A situation where the same artifact has been changed by multiple people, we term it as direct conflicts. Let's assume another situation. In this case, both Pete and Ellen are working on separate files. However, if you see, the file that Ellen is working on is dependent on a file that Pete is currently working on. A situation where a conflict arises because changes are made to different artifacts is called indirect conflict. In this situation, the CM system will not register any error because the changes have been made to different files. However, at the build stage, when all the changes are integrated, you'll have a build failure. So we see that coordination in software development is really important, and there of course have been efforts in how to better coordinate software development. There have been two approaches, pretty much. The one is called the formal approach to coordination, and the other is the informal approach to coordination. The formal approach to coordination states that if you have a big task, let's separate it into smaller tasks, smaller units, assign them to developers, and specify well-structured processes for development. For example, let's take configuration management systems. In this case, you have each developer checking artifacts out in the workspace. There is specific protocols of how to check it out, when to check it in, and what is the synchronization process. The strength of this approach is that it is insulating you from others' activities. While you're making changes, you're not interrupted by others' changes. You don't have overrides. Their changes don't break your workspace. However, and it's better control over the development process. The group is given preference as a whole. The entire process for the group is defined, and it is scalable to large groups. The drawback is because you are in your private workspace, you are insulated from others' changes. This insulation becomes isolation. You lose the context of work for the entire group, and when you're trying to synchronize, you might have synchronization problems. I'll talk a little more about the traditional CM approaches, configuration management approaches. There are the two approaches to CM system. One is the pessimistic approach and the optimistic approach. The pessimistic approach believes in locking an artifact when someone has checked it out. Well, this is good because then you do not have the situation of direct conflicts. You make your changes, nobody else can do changes. But this comes at project delays. Now let's assume you're Andy, right? Andy has gone to the wedding, and Rob here is waiting for his changes, and he cannot get to it because Andy is happy in a wedding. So, and indirect conflicts are not addressed in this approach. To overcome this problem of people waiting for others' changes, there is the optimistic approach. This allows multiple people to make changes to the same artifact. There are automated merge tools that help you in merging your changes, synchronizing your changes. However, if the changes are overlapping in nature, it has to be manually resolved. Even in this approach, indirect conflicts are not addressed.
Yeah, but also direct changes, your functionality might change even if the areas you changed didn't overlap, and that's also not addressed.
Could you repeat that? So in functionality?
One person changes this part of the function, the other one this part. They don't overlap, but the functionality changes and they are affected by each other.
Yes.
That's also an issue that's not addressed in there.
That's true. So what we see is like the key observations about formal coordination approaches is that the workspace that is given actually is good because you're not interrupted by other changes, but you lose the context, right? You do not know what the other changes is, if the other change is going to affect your work, affect the program or not. In a blind merge, the problem brought on by Stefan would be overlooked, and you will assume things are fine until at the build stage where the workspace or the program would fail. And currently, the opportunities for breaking the bad isolation is limited because one, any information that you get is from the CM system. If Andy and Rob are working in the private workspaces making changes, you would not know about it until they actually check it into the repository. And secondly, you will know of this change when you actually interact with the CM system. You make a query, you check in or check out, otherwise you have no idea. And as we said, it addresses only direct conflicts where there are overlapping changes or the same file has been changed. So in essence, we see a specific form of coordination is enforced and it is limited by the process underlying the CM system. If we take a big step away and say like, okay, how does the informal coordination approach work? The informal coordination approach works by believing in sharing information continuously. The idea is, as a user, you have awareness of any activities going on in the project. You are told of very fine-grained details, sometimes even mouse clicks. So you always know what's happening around you. You can take an action. However, let me say the strengths first. So this raises the awareness. It's flexible. You can take what action you want. You're not dictated by a specific process. It promotes synergy. If you know this change is important to you, you can talk to someone. You can make better solutions, and it places the user first. You have the information, you have the power to take action. However, the weakness is all this information that is provided to you, as we all know, we're very busy people, it's too much information, we quickly get overwhelmed and actually stop looking at all this information. And because of this, it's also not scalable to large groups. The key observations that we can make is then the informal coordination strives towards increased awareness, and there are the both good information and the bad information. Good information is, yes, we know what's happening around in the project, but this information quickly becomes overwhelming, and we actually sometimes even stop looking at that information, which is bad. The current opportunities for filtering out extra information is limited. It requires the human being to understand what the information is, if it is relevant, if it is useful, have the time to look at it. Requires context switching. Many times the information comes in different forms. It's not just in your development editor. You have to stop something, look at a different monitor, start a new application. It distracts you. And it does not currently explicitly handle dependency information. It will only tell, okay, Rob is making a change. And you have to understand if your changes are dependent on Rob's, if Rob's changes has any effect on your change, what is happening. So what happens is, in essence, informal coordination demands extensive human intermediation, which limits its use to smaller groups.
Just a quick clarifying question. So by informal coordination, do you mean both just kind of human-to-human contact, things like working in the same room so you can be aware of what each other is doing or going, and knocking on each other's office doors and say, hey, what have you been up to today? There's kind of that, but then there's also human-human, but sort of mediated by a computing system. I
was meaning more human mediated by the computing system, like CSCW, where you have video portals or other kinds of awareness mechanism.
I see.
Because the human-to-human is the best form, usually, face-to-face, but sometimes with locations and distribution, you cannot go and talk to someone.
Yeah, it seems like the human without the computer has a lot of the same problems anyway that you sketch out here.
Yeah, moreover, you get distracted by other information, and right. You just never ever reach the topic. Right. Okay. So we see that there is this problem. So the process-oriented approach is not the right fit. the totally informal approach is not right either because there's so much information out there. So what's happening, I call it coordination in the wild, is in the real industry, we see that usually the formal approach, like a CM system, is the predominant solution for coordination. Even with this, there's a high incidence of parallel work. A lot of people make changes to the same files in parallel. And the way they go around the coordination problem is there's a lot of informal communications. You have email, you have IM chats, you send out an email before and say, hey, I'm going to commit, and these files might be affected, make sure you know what's happening. And we have also seen there's a race conditions because the CM system allows the first developer to check in their changes. It's the second developer and thereon who has to actually do the merge conflicts and resolve the problems. There's this race condition, like, oh, okay, Tom has checked out the file 3 days ago. The release is coming in 2 days. I better finish my changes as soon as possible, maybe sacrificing quality and get my changes in the repository, which is not desirable. And if you want to have information about how somebody's change is affecting you, you need to understand who has made the changes, how is the technical dependency between the artifact that they have changed and you. Go ahead and talk to them. That's the only way you can understand dependencies and what's happening in the private workspace. So our approach is something called continuous coordination. So what we're trying to do over here, so in informal coordination, we have these specific synchronization points. That's only when people come together and they reconcile their changes. Here we had informal coordination where information is continuously passed. We say both of these has weaknesses. How about we go and combine both? So you maintain the formal underpinnings of a CM system, but instead of being isolated, you have information sent, relevant information sent, information that is filtered to you based on what kind of work, what kind of artifact you're working in. And the amount of information could change based on the kind of task you're. Suppose you're debugging, you want to talk more. You're just writing code, you can have the option that you don't need so much information coming in. So we would have scalable systems, flexible, we'll raise the awareness, and we place both the group and the user first. You can have the option of retaining some information, filtering out information, but it is again for the entire group. How do we work? Of course, that would mean we have to have computation-intense, extensive programs that understand what is information that is relevant to you, what is the dependency, what is that affects you. And it sometimes requires more individual effort for the group benefit. It requires that the individual keeps an eye out for the awareness icons. Individual actually says, okay, I'm committing in, send in some commit like not empty logs, but some information so that it benefits the entire group. I don't have to go there. So my objective for dissertation was, how can we support continuous coordination by allowing the good isolation? You maintain the formal underpinnings, you have the workspace, you don't get interrupted, but you have an idea that when someone's changes come in, it's going to affect you. It doesn't break your workspace right now, but you have the knowledge that it's going to happen. So you can early detect conflicts, and therefore resolution of these conflicts would be earlier and presumably easier. This would then mitigate the impact of direct and indirect conflicts. So my approach was to combine the formal process-based checkout check-in model of CM system and enhance it with relevant information sharing to create awareness of ongoing parallel activities. What I'm trying to do is, while a developer is in their private workspace, they are told of which other artifact is being changed by whom. What is the severity of the change? What is the magnitude of the change? The whole file has been changed, few lines have been changed. It just gives an indication of the importance of the change. And finally, what is the impact of the change? Fine, like only 5 lines have changed, but you have changed the API that I'm dependent on, so it is important to me. And to do so automatically and continuously. So it's not only when the developer goes and queries the repository or checks in that, oh, everything is broken, but you are given the information earlier on and also unobtrusively. This approach is embodied by the workspace awareness prototype that I've built called Palantir. So this is again to reiterate the point that the hypothesis of Palantir is that by providing information of relevant activities earlier to the developer, They would be able to place their work in the context of others' changes. They would be able to then have the opportunity to self-coordinate their actions, thereby reducing the magnitude and the occurrence of both direct and indirect conflicts. This is the architecture that Palantir has. Things in blue over here are generic components. Right now it's the Eclipse platform with the CM plugins. Components in orange or yellow, they are Palantir specific components. Arrows show information flow. Here there's a replication of both Ellen's and Pete's workspace to give an idea of each client has information. I'll be going through each of these components, so let me start with the first component. So I won't be talking about the blue components because they're generic CM components. The idea is there's a workspace wrapper whose task is to intercept workspace activities. There's a check-in, there is a checkout, there is a change in the artifact, there is a local save. So it interprets these workspace activities into Palantir specific events. So what this does is it decouples Palantir from the underlying CM system. You can build different wrappers for different CM specifics and you have the same system working. It also determines whether the activity is relevant to Palantir. If relevant, it generates the Palantir event. As I said, it's unique per CM system because it wraps around the CM specific actions, command line, or it listens for listeners. It's unique also per editor. Right now we have Eclipse editor, and it is and should remain unobtrusive. So the user does not have any idea that there is underlying Palantir wrapper or Palantir layer. They interact with the system as they would otherwise. Here are the series of Palantir events. So what we have tried to do is, instead of capturing a particular action that a person might do for CM system, like a check-in would be a commit for some other CM system, what we are trying to say is, what are the states in which an artifact can exist in the workspace? It's a populated state, you have taken it out, put in the workspace, you might synchronize it, changes are in progress, you're making changes in a workspace, changes have been committed, they have been reverted, and others. There are two extra events over here which says more about the kind of change. So in the metrics change, we have that artifact has changed. It could be the number of lines of code that has changed. What are the APIs that have changed? And impact is if an artifact is being impacted by some other changes. Okay. Next comes the Palantir Server. The main task of Palantir Server is to store all the events of the workspace. So at any point of time, we can understand the evolution of the project through workspace activities. Also, if you go disconnected, when you reconnect again, the server can bootstrap you with all the past activities that you had missed. Also, when new clients connect, you can have download all the activities of the project that has occurred since the start of the project. So you don't lose out on the activities. It's again common to all CM systems, and it is unobtrusive. Next comes the Palantir Client, one of the only things that the user actually sees. So first one is the internal, that it's got three components. The first component is the internal state over here. It maintains an overview of both local and remote workspaces. So each client has a view of all versions of files, all ideas, all changes that have occurred. So it's not that they store the files, but they just store an interpretation of how the files have changed. It stores events that you might generate during a disconnect. So when you reconnect, it transfers this to the server. And if you're disconnected, it attempts a connection with the Palantir server the first time you carry out a CM action. So it knows, oh, if you're trying to do a CM action, you must have got connection back. Let's try connecting to the Palantir server. There's the extractor. This is mainly to enable the user to filter out information that he's not interested in. So you could choose just a set of workspaces you're interested in, the kind of authors, the kind of files, artifacts, or even the kind of events you want to see. It just filters it out so the user has less information to deal with. And then this is the visualization that actually organize and display the events. So I'm going to walk you through one of the visualizations of what a user would see.
Can I ask you a question about this?
Sure.
So you mentioned the internal state that it stores events generated during a disconnect. Does that mean that the workspace wrapper in the event of a disconnect will talk to the internal state mechanism of the client instead of the event database on the server?
Yes, you're right. There should be an arrow going up there too. So it stores as a file system, just as a text file, log file, and once it tries to connect, it transfers all this information to the server. Right. Okay, sorry. It's always unobtrusive, and it is same for every CM system and editor, so it doesn't change. So let's start with the visualization over here, where it's Ellen who has populated her workspace with the projects. This visualization is called fully graphical visualization. Every box over here is an artifact. It could be a file, or it could be a directory with other files inside. Once she has checked out the artifacts, let's assume that she starts making changes. As she starts making changes, we see that the file headers have become green, saying that this file is being changed locally. There is a question mark over here which says that the changes are in progress. We don't know what's the extent yet. Once she saves it, we see lines appearing which would show the extent of the changes that this person has made to the file. And now we see there are layers appearing. What's actually happening over here is Ellen has checked in her changes to spell, so we see an exclamation point. I don't know if you can see it or not. And over here, we see these little two bars appearing which says what is the change to that particular file. Also, since it is CVS, as soon as you check in, you can make changes again. So it assumes that Ellen has started making changes to this file again after her check-in. There's another layer over here which is red, which means that someone else, say Pete, is making changes to the same file. That's why there is a red bar. And he's also started making changes to the file right.
I have a question. You said that the red and the blue bars tell you about how much change. What's the definition of how big they are versus how much white space there is?
So the higher the line, that would mean the more the changes. So it's based on lines of code that have changed right now.
And what's the difference between red and blue?
I'll talk about it later in detail. The blue means it's about just showing how much the file has changed. It's the severity, what I call. And the red would say what is the impact of the change. So the idea is that this particular file is getting impacted by someone else because of changes. So it gets clearer when I talk later about another visualization. This is a little confusing with the red and blue over here. Okay.
Just a couple of other details. So we have 3 instances of spell there. They all represent, well, let's see. It probably represents 2 different files, right? One is Alan's, and 2 of them, the 2 green ones are sort of Alan's, and the red one is Pete's, right?
Yeah.
Is there meaning to the spatial layout of these files?
So the idea was you'll see a layer, you would know how your changes have occurred, and when others are making changes. It might also occur that the red would have occurred before she had checked it in. Then you'll have a green, red, green. Then you would know like the red has occurred while you're making changes, you'll have a conflict that will come. So this shows also like, she has finished her changes, so she's fine. He's also kind of fine because, he has started making changes after she has checked in. But in his view, he would be seeing a green over here and 2 reds, and he might know that, okay, Ellen is making changes to the same file again, there could be a conflict. So it was just layered to show time as well as parallel actions.
And the red and blue bars on the left, does that apply to all the files that are in the box?
Files that have been changed. So when you do a local save, it will calculate the difference.
Okay, so in the case of the example that's on the screen, the red and blue bars are sort of aggregate over write and spell, those 2 different files?
So what do you mean? So for this, because they have actually checked it in, this person, so there is real changes. And in these 2 cases, we are assuming that they have just like, hit 1 enter or 1 space. The line is too small to be seen. So they have just started working. Right. So as you are sitting and changing your file and you see someone with a big blue bar, you will know like, okay, there's a lot of changes already there. Let me go find out what's happening. Right. Right. So that's the idea.
Okay.
Okay. Sure.
What's the number after the header? So you see spell 1, spell
1.1, 1.2, so you'll actually know the version number.
It seems like the second green one should be spell 2 since she's already checked in spell 1. The one with question mark, shouldn't that be spelled 2 now?
So actually it should have been, so what I was trying to do was like this should have been 1.0. That was the beginning that you started, so you were 1.1 and 1.1. So what we are saying is you have checked it in, so this shouldn't be 2, this should be 1.2. It's my fault. So CVS goes 1.1, 1.2, 1.3, right?
Right. So then wouldn't it be the first spell one would be 1 point?
This should be 1.1 because what we are saying is you have made the changes and stuck it in the repository, right? So you're no longer 1.0, but you're 1.1 now.
So when they check it in, you're incrementing.
You're implementing it, but this particular file is again you're working off the version 1.1. So that should be 1.1.
Okay.
And this should have been again 1.1 because we're assuming the Pete has checked it out. So that's my bad.
Okay.
Thanks. Okay. Anything more? So and etc. Right? So we have more files that are being worked. We see more action taking place. Right? Another cool part of this visualization is you can do a pairwise comparison. So because if lots of people are making changes, you might have big layers, lots of changes occurring. And I'm interested in knowing how does my change relate with this other developer. So let's assume that Ellen is the driver of the workspace. So she sees for her visualization there's a lot of layers. There's an orange layer, there's a red layer. You can choose the colors, of course. She wants to see, okay, how does my changes relate with Pete's? And then she can have an option of just saying one-to-one comparison. So she sees how her changes relate with Pete, and she has deleted a file over here. Same thing she can do with Mike. So the idea is we're trying to help the user filter out details and know like, okay, Mike always has very hard problems. He always makes changes that are not good. Let me see how my changes relate with Mike. Right? Go ahead.
Not to belabor the point, but the horizontal bars that are now over Pete's small tiny files in the boxes,
Yeah.
are those really the vertical ones just turned over?
Yes, just turned over. So because the small one was very hard to see, so we moved it. Okay. So that was a fully graphical visualization. It does take a lot of space in your workspace, right? You'll have to probably have a screen separate it out. So what idea of Palantir is we give you information that is embedded and small cues. You can see that information, and if you want to investigate it further, then you open one of these other visualizations. The same idea is repeated in Eclipse. So red ones over here is the impact of a change, and the blue one over here is the severity of a change, by how much the lines of code has changed. There are other visualizations that you can have. Similarly, there's a ticker tape that keeps saying information just rolls by. You can set, I want to know information that has severity of 50 and above, only then show it to me. And once you have that information, you can open this other view to see what's happening. Again, over here, this is Ellen's changes, Ellen's workspace. Things in green are changes that she has made. Bars in red are changes that others are making. You can click on a particular file, it's pasted over here, and get the details of how that particular file has changed over time. Right? So to give a little more information about what I mean is a fire alarm.
I don't think so.
Okay. What I meant by severity and impact, right? So what severity analysis mainly tries to do is calculate the magnitude of a change. What is the size of a change between two versions of a file? There are two kinds of severity, the artifact severity and the directory severity. The idea is that you don't want to just know about the artifact, but that information should be communicated up the directory tree, because sometimes your folders are collapsed. You want to see, okay, the project has changed or not. The way it is done right now, artifact is a simple how many lines have changed over the total number of lines. Directory severity gets a little complicated, so it's the actual severity over the possible artifact severities that could be there. So let's assume that here foo has changed out of 2 files. Foo's change is 50%, but if you move up the directory has changed by 1/4. So it's 25%. For going one step up in directory A, you had directory B that could have changed 100% and directory C that could have changed 100%, but only B has changed 25%, so it becomes 12.5% for the parent directory.
When you aggregate these values, are you aggregating the percentages or are you aggregating the number of lines? Possible lines.
Total possible lines.
Okay. So if somebody has one small file that's only 5 lines and they change all of it, it won't really have much of an impact on its parent directories, right?
Yes, it will be a very, very small thing. Yeah, but probably I should look at percentages then, because then it will become, I don't know. So this is a little modules that you can change. So what we finally want to do is like give an option of choose which kind of severity mechanism do you want your team to follow. But the question is that the entire team has to follow the same algorithm, otherwise different people would have different meanings.
Sure, right. But I mean, it'd be quite common that you'd have one file that maybe just contains one item in it, one line, and it's changed, maybe it's a version number, and so or some another directory path, and they changed out 100% of that file. Quite often, you don't want to raise signals that say, "Oh, my project's changing."
Okay.
So I think the way you have it is
Okay, good.
One question for the severities. If the severity already is a percentage, it would be just sum of all artifact severities divided by number of artifacts. Because possible artifact severity is always 100%.
So the problem with
Percentages.
yeah, but it's on lines. So
Okay, so we are talking about the magnitude, not the severities.
the magnitude of the change, basically. So the severity says that by how much the files have changed, which is based on lines of code that have changed. Because the problem with one problem which we had risen before was by just number of artifacts was if a file was really small, as he said, it's really small, maybe inconsequential, but it gets changed a lot. It bumps up the severity for the entire directory a lot higher.
Okay.
So we're giving.
In this case, you're talking about the magnitude and the formula is just incorrect.
Okay.
Because
Okay, so I got it.
that confused me because I was thinking about the severity was defined as a percentage. That was
No, so this is just to give an idea of percentage of files that have changed. It's not on percentage, but lines of code.
the first
That's
bullet
correct.
says magnitude.
Yeah, but in the directory severity, you're talking about the sum of all magnitudes, not about the sum of all severities. That's what was.
Right. Okay.
Okay.
Sorry.
To ask a sort of different question, have you thought about computing severity based on lexical, syntactic, or semantic properties of the code that's actually changing as opposed to just the lines, which could be its consequential white space?
So that's what is the next slide about.
Right.
Impact analysis. So what we mean by severity, it throws people off a little is just by saying how big is the change. The next comes what is the impact of the change. So what we are doing right now is looking at API-induced indirect conflicts. So if the API signature is changing, or the method signature is changing, or the class signature is changing. So we look at, what's the dependency in your workspace? If you're dependent on any other files, what methods or what classes you're dependent on. And if that class or method is changed, it signals your workspace that you're going to get affected. Does that make sense? I'll explain through scenarios, it'll be easier later on. So there are 3 levels of analysis. One is your local workspace. Okay, I have made a change to an API. I need to go ahead and if I have an impact on my own files, I need to go back and change it. It lets you know. There's the remote workspace, right? So there is this other person in her private workspace, Ellen, who's making the changes that will affect you. You right now have no way of knowing if there is a change by Ellen that will affect you. Also, it could be that in the repository, there would not have been any conflict with Ellen's changes, but you have added some new code that actually brings the dependencies on Ellen's work. So this brings in cross-workspace impact analysis. It looks at your current state, your current dependencies, and what her changes are right now, and analyzes them to find out if there is a dependency conflict. And then there's the repository level, which means once Ellen has finished her changes and stuck it in the repository, then you will know that this is a real conflict. There is no chances of being reverted back, so you have a conflict. We also present the effect both ways. So outgoing conflicts, the artifacts that are affecting others. So if Ellen is making the changes, she would be notified, as well as Pete, who's actually having the conflict, will be notified. Go ahead.
So if I work on the kernel of an operating system, am I going to get a big gigantic bar that says every time I make a change that I'm going to affect the entire operating system? I know I'm going to affect everybody, so I'm just like, it's sort of a spurious warning, like if I work at a really low level of the architecture of the system, like, yeah, of course, everybody depends on me.
Yeah, so you will be notified that you are, let's assume that you want to find out, okay, if I make the changes, how many people are currently working on it that will be affected. right? So you say like a what if and see like, oh, lot of people, and you know now it's a release, you might do it later on. But the more important part is like, you know you're getting affected, but all these other 5 people who are actually using the kernel would now know, oh, Andy is going to make the changes, which is going to affect me. So it's, in this case, if you already know the significance, it's kind of redundant, but the other people would be benefited by knowing that Andy is thinking of making a change that will be affecting them. So let me go through a couple of scenarios that will make it easier. Too bad it looks like a yellow over here. So let's assume over here, Pete is making changes to file A, and we see that B is dependent on A. So this is again not very new information. Pete should know that B depends on A, and when he does an entire workspace compilation, he will find it out. But this is just a heads-up warning that, hey, you're changing A, this B would be affected later on. So that's what we call is the local workspace level analysis. Let's take another scenario where Pete is making changes to the file C over here, and Ellen is making changes to D. We know that Pete is dependent on D, that Ellen is changing. So we know there is a potential conflict that is going to arise. And we call it the repository level. So we are following the traffic signal. So green is the lowest significance. You know about it. You would have found it out anyways. With yellow, we are doing, it's relatively low severity or low warning signal because, she might just revert her changes back. So we do not know for sure if it's going to be a conflict or not. So because of changes to D, C would be breaking and Pete would be notified about that. Now let's assume that she actually finishes the changes and checks it in. The signal becomes red now because now there's a definite conflict because the change is in the repository. So this is what I meant by outgoing and incoming conflicts. So both Ellen would be notified that her changes are breaking others' workspaces, and Pete would be notified that some ongoing changes that Ellen is doing is going to potentially break his workspace. There's another scenario that is very hard to catch. Let's assume that C over here depends on B as well as D. Pete changes the file B and Ellen changes the file D. So both these files are separate. Nobody's working on C, but eventually in the final build, C would be affected. So with my analysis, both Pete and Ellen would be said that their changes are going to affect C and that they should keep that in mind. Any questions?
So other than the people making the changes, keeping things in mind, is there any sort of idea for an automated system to warn the people who work on C or who own C that there's changes coming, like even if you're not thinking about this, when they check in, you're going to have to start working?
So this is the Eclipse View. So this is exactly what happens. So you have the file. So in your Eclipse Package Explorer, what we do is we annotate with these little bars. And if you right click on this artifact, this view pops out, which says like, okay, so your file credit card that you're working on currently is impacted by Pete. This is the one that is impacting address. So I'm doing credit card is impacted by address. The changes are done by Ellen. The changes are currently committed. That's with the red bomb over there. The timestamp and what was the reason why your file is going to break. So while you're in your workspace making changes, these little icons pop in, and if you're interested, you go click on that and it gives you more information. Similarly, the same file is again impacted by changes in customer. These changes are still in the workspace, so you don't even know what those changes are if it was in a regular CM system. We also say, okay, let's give a warning to Pete because you're working on this credit card and you depended on payment. And someone has added a new method in payment. So, just wanted to let you know that there's a new method in it. Because a scenario that like this could happen is credit card is calling on payment and the entire initialization code was in the original constructor. Then Ellen goes and decides, okay, now the initialization code should not be in the constructor but should be in a new method called init. So API level there is no real conflict, but behaviorally it has changed. So I'm not looking at behavioral analysis right now, but I'm saying, okay, this new method is added, it sounds like init, so you are using the constructor, you would want to go and check out this method init over here. Questions on this? Andy? Okay. So for evaluation, first is the proof of concept, right? Yes, I built it, so it is possible to have workspace awareness. I have built it for 3 CVS systems, 3 CM systems, RCS, CVS, and Subversion. Use the JSFin as a front end. So all that needed to be changed was the Workspace Wrapper. Everything Workspace Wrapper up remained same. It was relatively simple, 500 or so lines of code. I also did for Eclipse integration. We have CVS and subclips, 750 to 800 lines, and we have the Workspace monitor that actually traps all the local saves and local changes to the file through Eclipse listeners. Second question. So if we actually show it to user, does it help? Does the hypothesis that showing information of relevant activities changes the behavior, leads to fewer conflicts actually true? What I'm doing is a controlled set of lab experiments. I'm doing 3 sets. I finished 2 sets and the third set is ongoing. The scenario is the person is a 3-person team. The subject comes in and is told that he's working or she's working collaboratively with 2 other people. The other 2 people are actually confederates. They are solely responsible for introducing conflicts into the project. I did this to ensure that the conflicts that were introduced, fixed number of conflicts, and their nature was the same. So the confederate is basically a research personnel who runs scripts that introduces conflicts as the subject goes through the task. I observe the time to identification of conflict. If you put the icons, how soon do they notice it? Do they do anything after they notice it? And how long did they take to resolve the conflicts? So I have control and experimental groups. Control is without Palantir, experimental is with Palantir. And I had done random assignment of subjects. So people come in, I just randomly, using the table of random numbers, assign them. However, I found there was a big difference in the times because it was Java programming based on the technical aptitude. So for the third set, which I'm doing for statistical analysis purposes, I did 3 things. First, it was only text-based, so there was not much of difference because of the Java knowledge. I have a survey on the background questions. How good are they in CM systems? What is their experience in software engineering? And the text was in geology, if they're interested in it or not. So this was, and then I stratified them into 4 groups, and each strata I'm doing random assignment. This is to minimize the changes or the differences in the technical aptitude. So I'm breaking. Go ahead.
What's the subject population?
Undergraduate students, graduate students, and programmers in school. So most of them are computer science undergraduates are the majority. So for the experimental hypothesis, I have 5 of them that finally would lead me to the conclusion of my main Palantir hypothesis. The first is, do subjects notice the icons? Do they take any actions? Are conflicts detected earlier in the project with Palantir? 4 and 5 is, with Palantir, conflicts should be easier to resolve. And 5, time to completion for the experimental group should be shorter because they are going to have the resolutions done faster. For 1, 2, 3, I have proved that yes, it works. 4 and 5 were difficult to test because in the example project, the conflicts were really easy. So it was not much of a difference, not hard to resolve them. The confederates are always there to talk back and discuss things. It was not that the person has gone off and you have to wait for them. And 5, the experimental group spent more time because they were actually chatting with the confederate and resolving the problems, whereas the control group left the conflicts in the software. So the quality was bad, even though it was faster.
Was it sort of a think aloud protocol? Is that how you were able to tell whether they were noticing things?
The first 2 sets I did think aloud. So they would say, oh my God, oh no, and things like that, and I was observing that. However, I did an exit interview and asked them about think aloud process, and they always said it was not nice. They had problems doing it because one of the reasons was few of the students were international students, and thinking aloud in English was an added cognitive task. So for the statistical analysis, I'm not doing think aloud, but I'm actually screen capturing the entire video, entire process, and I'm having the video file that I'm looking at. And so if they notice and did not take any action, I will not be knowing it. But if they notice and open the file or hover over the file with the icons, I would know.
Right. So. And from the previous ones where you were doing think alouds, did it seem pretty typical that if people noticed it, they took an action?
Yes, I was really impressed and surprised by our undergraduates. that they noticed the icons pretty fast, almost within a minute, and they opened that file, they found out what the changes were about, and in the first set, if it was a changes in progress, the Palantir tool would not tell who it was. They would actually chat with both the confederates and say, are you making changes to it? What are you making changes to it? People did not want it to move on if there were any conflicts, or they thought they would have to rework. And one of the reasons was in task 2, they would have a conflict which took a lot of time for them to resolve, so they're extra cautious moving on. Right. Okay, so set 1. So the first experiment that I did was to see if impact analysis was actually useful or not. So this was primarily geared towards testing the effectiveness impact analysis in detection and resolution of indirect conflicts. So the experimental group had the entire Palantir with Eclipse and CVS, and the control group had just the basic, so without the impact knowledge, but just the same file is being changed or not. So the idea is the developer should be aware of their dependencies in mind, and that's how they currently find it, to see if that's true or not, or would the added warning signal by Palantir help them. It was in Java programming. There were 12 tasks, 4 of the nature of direct conflicts and 4 indirect conflicts. I had limited the time to 1.5 hours. There were 10 subjects in each group, 10 subjects, 5 in each group. But out of that, two data from 2 people had to be thrown out because they were really slow. They had really trouble with writing Java. They didn't even know how to use semicolon. It's kind of surprising. Even though they had said they were pretty okay with Java. So that was the first question. Do you know Java? Yes. And then they actually do it. It's like, it was really painful sitting there and watching them do that.
How big a code base was this?
This was 15 files, but each file was like 20 lines or 5 to 20 lines. Really simple. A store project that we made was inventory control. So the dependencies were pretty obvious too. They would say like, use the customer constructor to make a new file or something. Mm-hmm. So the tasks were very obvious dependency-wise.
And also dependencies between the files were, I assume, quite easy.
Yes, so
a huge tree.
Yeah, it was this very small file. So if you actually paid attention to the task and the blue icons, you could not have missed it, as we would see that it happened. So it was print all the lines of address in the shipping address. So the file shipping address would use address to print the line. If you see a blue icon in address, duh. But people still missed it. Okay, so the resolution rates over here. So for direct conflicts, of course, we have very similar results because both groups had the Palantir icons. We over here have subjects notice conflict and address it immediately. So you see something, do it. You see something and like, okay, maybe it's not going to happen. Maybe I'll just go over. But at commit stage, you'll find the problem and then you'll be addressing it. So that's why the detection or resolution rate of direct conflict is the same for both the groups. No wonder, no matter how you work, at commit stage, you will find the problem. Subjects notice conflict, ignored it, problem remains, or did not notice conflict over here is because the direct conflicts were spread over 3 kinds. One that was done before you entered the task. See, there was already a conflict in the repository. One was made while you were in the task. It was a during phase. Out of that, one was changes in progress. So it would not conflict when you committed your changes. And the final conflict was after you finished the task, the conflict was introduced. We noticed that after a task was done, you noticed it, nobody took any action. It was not their responsibility. They were not worried about the well-being of the entire project, even though I had told them, you are an important person, you need to make sure things are fine. People did not do that. And over here, the big problem is because they did not notice the after conflict and the conflict that was still in progress, they didn't have a problem with commit. Any questions on that? Okay. So for the indirect conflict, we see there's a significant difference. Subject noticed conflict, ignored it, problem remains in code over here is they found there was a problem, say in address. They said, it's not my problem. That person has changed it. He should change it. And this person over here found all the incorrect conflicts. She had worked in a team before. She was really paranoid about changes. Before she started a task, she would synchronize the entire workspace. After she finished her task, she would update her workspace and then commit. So the changes were very obvious and it was all dependency level changes. So the workspace would break and she would find the conflict.
Just a question about the y-axis. It says the number of conflicts, but the title says the rate. Were there 8 direct conflicts and 8 indirect conflicts in both of the groups?
Yes. So we had 12 tasks. Let me go back over here. 12 tasks with 4 and 4, but they were very slow because the time was limited to 1.5 hours. They could only go to like task 6. So we had only 2 conflict of each kind, and there were 4 of each. So 4 subjects into 2 conflicts. So 2 direct conflicts, 4 subjects, is 8 conflicts total. Same for indirect conflicts. So this is just number of conflicts out there and how much they found out. And this is if they found it and resolved it.
So are any of those numbers correlated to each participant in the study?
I have the data that, yes, it does.
I mean, like, is the number...
No, this is aggregation of all the subjects. So it's just like just if they found it and did anything or not. But it's not per subject. The colors are noticed it, took it or not.
I'm just asking you, as far as what you know of the data, like, was the white bar that's in DCC column, the first column, is that from one person? Just he didn't notice any conflicts?
No, I think this one was 2 people or more than 2 people based on the after conflict. They would not notice it because, they are working. They saw the blue icon, but they was like, I'm done. I don't care about it. So that was pretty much throughout the 4 people.
Sorry, I'm still confused. So each of these bars represents 5 people aggregated
4
together.
because they have 2 outliers.
Oh, okay.
So that's a 4 into 2 is 8.
And how are they aggregated together into one bar? Is it averaging or?
No, it's just the whole number. So there were 8 conflicts in together. It's a sum.
see.
So out of that, I think 1 was they actually noticed and addressed it immediately. The other 2 1 to 5, 4 people saw it, but they didn't take any action. So it is subjects into number of conflicts.
Okay.
Because it's really qualitative data. I don't have much data, so I just added everything up and seeing what it is.
Right.
But even like with this little data, there is significant difference in these 2 groups. If I take the binomial distribution and say with what percentage confidence they will be separate,
Yeah.
these 2 groups are pretty separate. These are almost the same. So we see enough difference over here.
Yeah, there's little enough data that it might be interesting just to see individuals rather than aggregating it.
Like I could do that.
Because then we could judge how much variation there was between individuals in the different groups.
True. So per person, how these 4 parts were,
Right.
or like 2 parts were. Okay, I could do that.
So it was on a slide before, but now I've forgotten. The difference between the control set and the experimental set for indirect conflicts, I thought you said that in the control set, people were still aware that a file was being changed, but in the experiment set, they actually had the impact analysis.
Yes.
So that's quite surprising to me that you'd have this big difference, so that people in ICC still knew that the file was being changed, but they didn't notice it. But then when they had impact analysis,
Because there's this red bar. So what happened was I saw while they were doing a task, they opened that file and they only looked at that file. So even though the task said go get address, they went, got the address information and came back. But if there's a red icon on the file that they were working on, they were interested in it. So it was very, all the subjects even now are very focused. If the file that they have to work on has an icon on it, they take action.
so in the control set, you said that there was a way for them to tell if the file was being worked on by someone else, but they didn't get an icon? Is that
They got, so let's go back to this particular view, right, over here.
Yeah.
So in the control set, you won't have a red icon in credit card. You only have a blue icon in address, which means that address has been changed by someone else. But that changes is going to affect credit card. What would happen is the subject will open credit card, see there's nothing over here, make changes, and commit it. Even though if they open address, get some information from there for the file, and make changes in credit card.
I see. So they didn't realize that there was the dependency there.
Yeah.
Okay.
But if there's a red icon or a blue icon on the file, they are cognizant of that.
Okay.
Okay, sorry about that. Time to completion was the same, was all around, and some of it was because some people were very slow, some of the people were very fast in the Java programming itself. So there's not much I can say by just looking at the task. The only surprising part is this part. This particular number 3, task number 3. That was because the conflict was introduced and was changes in progress. It was indirect conflict. The changes were not committed yet. The experimental group saw the icon and they asked the other person, oh, hey, what's happening? When I go to check it in, it's like, oh, wait, I'm still working on it, take some more time. They spend more time in talking about it, but these guys had not found the conflict, so that's it. Okay. Moving on to experimental set 2. So I realized stopping them in an hour and a half was too short a time for them to complete the Java. They did not complete the entire task. So, there's some information which is missing. So for this set, I had control group was just Eclipse and CVS, no Palantir, and experimental group was entire Palantir, impact analysis, as well as changes in parallel information. The same project was used, 12 tasks, 4 direct and 4 indirect conflicts. No time constraints, but people finished around 2.5 hours. I was off by 1 hour. There are 6 subjects in group, 3 in each group. People at UCI are pretty wealthy. They do not like $50 and participate in an experiment. I also started around the midterm time, so I had very few subjects who were volunteering. This is again qualitative analysis. This was to test the effectiveness of Palantir in detection of both kinds of conflict. If you see over here, this is a direct conflict between control and experimental group. The rates are pretty same. It's again because they would identify the conflict at commit time. The only difference between these as well as over here is people would not bother with conflicts, direct conflicts, after they had finished the task. And even if they saw it, they was like, it's not my bother, I'll move on. Indirect conflict, there's again a significant change. The reason these guys actually found the conflict was at task 3, there was an indirect conflict that was changes in progress. Remember the one that was kind of weird last time? But at task 8, the same file that was causing the indirect conflict was scheduled for a direct conflict, so they had checked it in by then. And when the subject for the direct conflict, they updated the workspace and the other dependency broke, and they could find that conflict. So that's the reason why we have detection over here. And over here, there are I think one person who missed 2 conflicts. They updated the workspace. There was another file that was broken. They did not bother with it, and the red cross of Eclipse was overlaying the red arrow of the Palantir icon, so they just did not look at it. I have divided the time to completion in direct and indirect conflict. Again, there is lots of fluctuation just based on the Java tasks. Over here is the thing that the control group, this is the IC, indirect conflict that was caused by changes in progress. These people over here spend a lot of time talking and nagging the developer, nagging the other confederate. It was funny, they would skip the task, but 5 lines after writing the new task, they would say, are you finished? I want to make sure my tasks are done before they moved on. I spent a lot of time chatting over here.
Did you always do the indirect conflict tasks after the direct conflict task, or did you?
It was interspersed. So task 2 was a direct, task 4 was an indirect, so it was intermingled. So I just separated it out. Now it's direct conflicts 1, 2, 3, 4. They are conflicts, not tasks. Okay, so again, there's not much significance difference between the 2 groups here, time-wise. The final set that I'm going to do is on text-based analysis, text-based assignment, so we don't have the fluctuations because of Java programming. It's going to be again control group without Palantir, experimental group with Palantir. This time for text-based, I'm doing only 8 tasks and have 3 direct conflicts and 3 indirect conflicts. There's going to be no time constraint, but I have done 6 of them. They take hour and a half of the time, right from getting the tutorial and finishing. It's going to be a quantitative analysis, and this time what I'm trying to say is because this text, the workspace does not break and give away all the indirect conflicts. After the subject in the control group has said, I've finished, I tell them, you are the chief editor, you're the main person in the team, the textbook is going for publishing, make sure there are no consistency problems, make sure all dependencies are fine. And I also give them the hint of table of contents. Still finding not many people understand it. They're doing just paper-based formatting of it. It's ongoing. I'll have enough data. I have 28 participants, so I have 14 in each group. I should have enough statistical data to show the confidence level of that Palantir is better in its effectiveness.
So for this set, the dependencies between files have to do with cross-referencing and things like that?
Yes. So basically the 3 things, the list of figures, one of the pictures is deleted, table of contents, one of the chapters is deleted, and there is one dependency which is, these 2 are I think fine, it's easy to find. But the third one is a little tricky. It's one of the tasks asks them to use the name of a person as used in one chapter, and that name is changed in the chapter by someone else. So that's something that I cannot even ask the users to look for with hints in the control group. So.
Are the users participants in the study, are they computer scientists still, or are they non-computer scientists?
They are still computer science.
So, and have they had experience using the Eclipse IDE before?
Yes, most of the students, they are in their senior or that's third year and fourth year. That's senior and junior and senior, and they have been using Eclipse for at least a year. The person, as far as I have data, is for 15 people. The person with the lowest experience is 5 months of Eclipse, and they have had CVS or subversion, Eclipse experience, because they have to use it in their second year in a class, so they get to use it. So I don't have data for this yet. How much time do I have?
Let's say another 10 minutes.
Okay, so this is what I have done for my project, like for my PhD. Looked at continuous coordination, built the tool, evaluated it. I have also done a theoretical framework that is pretty complicated. It just shows up, it tells you how software collaborative tools have evolved over time. What is the paradigm that they have used, how those paradigms have changed over time. It's in the form of a pyramid. I'm going to go really fast. If you're interested, I'll be really interested in getting feedback about this particular work. It's not published. A smaller version of it was published in Eclipse, looking at Eclipse plugins, how they have evolved. But there's more work to be done on the entire survey as such. So let me move on. There are 3 strands, which are the 3 aspects of collaboration: communication, managing artifacts, and tasks. And then there are these 5 other layers that actually build the pyramid. It is how automated tools, how much support is given by automated tools. So it starts with the basic functionality when coordination is really all the users have to do it by themselves. Then we have rigid processes where there is well-defined structures, but you have to follow this process to get your work done. Then is the information discovery layer, where you find that the process is not working well. You need to go out and find who else's change is going to affect you. You have to go out and get information from the system. The next layer gets like, okay, so you need this information. How about we provide you in an unobtrusive and passive manner? And the final layer would be the integrated operations layer, when different applications across different domains can be seamlessly integrated. If I look at CM systems, how this started, it started as just like a database. Right? You stick your files in a database that others can use. It was pretty much open. Then comes the CM systems as we know now. You have certain processes about checking in, checking out, synchronization. Then it moved on to the information discovery layer, because pretty soon people found out you have the synchronization problems because of this isolation caused by workspaces. So things like CVS watch, where as a developer you can place a watch on a particular file, and when that file changes, you are informed about it. That's the communication part over here. And then also artifacts were more finer grained. We have like method level or smaller modules of code that can be versioned, so you have more control over the files. This is my work, which moves from just it being that the system has the information and the user has to go get the information, to giving the information into the private workspaces of developers. And this is where I want to go ahead in the future. Getting more seamless, information is easily available. It depends on what kind of task you're interested in or working on. So for future work, I have started working on 2 other small projects. I've designed them. This is called the activity viewer. What it's trying to do is give a project management view of it. How has your project evolved over time, but not just at the repository level, but looking at how each workspaces have evolved. Each of these bars over here show the changes to a file. The width of the bar could show if lines have changed 100% or the changes are small. We have the artifact view and the developer view. What this does, it places the stacks. Let's say this is a particular developer, and he has 3 artifacts that person has changed. So you would know what is the kind of changes the developer has done, what is the recency. As the developer or artifact is stagnant, these bars slowly go to the back. So at any point of time, you will know what is the status of the project. You can have a playback, movie playback, to show how your project has evolved over time. Another cool thing, since we are looking at workspace activity, we can say what changes are still in the workspace and what changes are in the repository. I still have to get real data to evaluate it. We have had open source project that we have looked at. This is, I think, game project. But then we have simulated the workspace activities, like changes in progress. We have just simulated it based on commit information.
So it's a whole discussion which we shouldn't have here, we can have later, but there are lots of privacy issues and things associated with having people's activities monitored and shown to their bosses, right? It becomes a system that people then try to game to get the best evaluation in their boss's eyes, right? So I think that's going to be a huge evaluation issue for such a kind of system. But like I said, that's a big discussion in its own right. So.
That's true. So this would be based on the CM information, that is information readily available anyways. That's one way out of it, but then the workspace information is, again, that they don't want to give in the visualization that is obvious.
I mean, it's sort of a similar phenomenon on the web where there used to be quote-unquote public information which you'd have to go to the courthouse to read, and now there's public information which you just go to a URL and read, right? And it makes a big difference, how you're giving much better access to this data than teams have ever had before, and that's going to shape behavior. So it's a big discussion about what effects it'll have and whether it's what you want or not.
That's true. I mean, if people start cheating and making changes, like over here, everybody starts with making changes to the GIF images. They want to change the looks of it, but this particular visualization does not make differentiation between the kind of artifacts. So you can keep changing the image and look good, but it's not really good. The other project I'm working on is for global software development. So this is actually the Microsoft API, the Virtual Earth. And we actually written a proposal for the MSR grant, $60,000 or something. There's a proposal out now. We're writing for it. The idea is each team is usually separate. In global development, they're the teams that are distributed across countries. It's hard to find out where they are located, what is their action, what is the dependencies between these teams. So based on my previous work, what we're trying to do is have the teams using the world metaphors. You have the idea of where they're located. This is an interactive zoomable picture. In this picture, the lines show dependencies between among the projects, among the teams. Over here, we have a circular dependency. Team in California, UCI, is dependent on New York, and New York is dependent on UCI. But we see this is red because there are some conflicts. You can right-click on it and say, okay, what's the kind of conflict? What are the files that are affected? Now you want to say, like, okay, now I have problems with UCI. Who should I talk to? So you click on the UCI icon, and you should get, say, the team structure over here. So the idea is to present different kinds of information. Like in a regular software project, you don't have information of the organizational chart or what's the kind of process they follow. So what you're trying to do over here is keep a history of the kind of process they have, what's the org chart, what is the preferred mode of communication, if this person is online active, not online active, what is the time view, is it night in the other project, in the other team, can they talk to me, even if it's a night, are they active, and who can I talk to now? Over here, India is in red because it's a public holiday, and even though it's daylight, they're not working. So this gives an idea of where your team is, what they're working on, if I can communicate with them or not, and if I need to communicate with them. There's one more level of zoom is inside a particular team, we would show who the people are and what's the dependency between them. I was sick during that time, but I look happy. So that's what I've done, and here we have a Hitachi big screen board, and this is one of the developers who's helping me. He's a master student, and he's showing that you can look at the timeline, which time these dependencies were, the release dates that show if there was any peak during a particular release. Again, he's looking at stuff. So in conclusion, I have worked on a system called Palantir that looks at continuous coordination. at the development stage. It tells you which other artifacts have changed, what is the significance of the change, is there an impact for the change. The idea is Palantir would then give you the knowledge to enable you to have the opportunity to understand the context of work and do self-coordination. It should therefore reduce the occurrence and magnitude of both direct and indirect conflict. I'm in the process of evaluating it. I believe that coordination is the underlying principle in the entire software development process, right from requirements to maintenance. Coordination between the artifacts and between the people is important. And users or developers should be flexibly supported through the tools as well as information to enable self-coordination. And that's pretty much it. Thank you. Questions? This is my website, and this is the tools website that you can get more information on.
I have a question.
Sure.
Maybe I missed it. How again do you specify to Palantir what the dependency between files are? It doesn't auto-detect that, right?
It does. So what happens is the Palantir tool looks at my workspace. Suppose both of us are working.
Yeah.
It does a dependency analysis on my current workspace. I use a third-party tool called Dependency Finder.
Okay.
So it has a dependency cache, and there's another set that works on your machine that looks at the API changes. And as soon as there's an API change, because I have the events going back and forth every time you save, it sends me the information, and my machine then sees, oh, this API has changed, I have this dependency, and it lets the user know.
Yeah, I must have missed the part about where you mentioned that tool, the dependency.
Okay. No, I didn't mention the tool name, just the dependency.
There was a tool, okay.
Yeah.
And then for impact analysis, so we're clear that we can use lines of code to determine what the impact is. What other methods have been used? I mean, have you tried this in a, what's the Java version of Spec Sharp?
Yeah.
Basically contract.
JUnit. That's
Contract-based programming, so you have contracts on your methods.
Like ESC Java, or,
Yeah.
or what's the follow-on called? I can't remember now. But this is preconditions, postconditions, that kind of
Right.
stuff. On
Okay. That's what I want to do for the next. So what I have done right now is API-induced indirect conflict. If the signature changes, I'm letting them know. What I was thinking of doing for behavioral analysis is have JUnit tests. So, if the test fails, then the behavior of that program has changed, and if you are using that program, you should be notified because the behavior of the program has changed. But I have not worked on it yet. Something that I plan to do.
What's the time complexity of the impact analysis? Like, is it proportional to the number of people who are working together, or proportional to the size of the code, or?
I don't know because I have not really evaluated with lots of people. But right now, there's an initial startup problem, startup time, because it has to go through the entire workspace and create the dependency cache. But this tool has a continuous monitor setup. So after the first cache is built, as you keep changing, itself creates a graph. It doesn't have to create from scratch. So there's initial startup time, and then it's easier after that. It's
Producing a graph on each client computer?
Yes.
And then comparing the graphs across computers?
Not graphs across computer. It creates a graph, and there's another little tool that looks at the changes per file to find if there's an API change or not. So once an API change comes, it just looks at the graph to see if you're dependent on that API and creates something.
the other possibility for this kind of dependency stuff is you could do the same tricks that Andreas Zeller and Tom Zimmerman do of looking for parts of the code that tend to change together, that get, changes that get consistently checked in together. That gives you a kind of probability of, if this thing is changing, what's the probability that other definitions will change as well, right? So that's a kind of a different way. In fact, that one is nice because there's no programming language semantics at all involved. It's just text, right? This part of the text tends to change when this part of the text tends to change.
That's true. But it's been done already. So I can incorporate that as a separate module.
But it hasn't been used as a probability.
Okay.
It's been used for recommenders and things like that, for program understanding.
Okay.
If you're looking at this, you should also look at that, right? But I don't think it's been used as a way to predict conflicts.
That's right. I can look at that. So the way it's built, it should be really simple to take off one analysis technique and stick in another analysis technique. It's all modular. So
Where would that be in your little architecture diagram?
Okay, let's see. How do I do this? This will be horrible. I have to go through lots of them. I should do it here. So the analysis technique should be at the workspace wrapper level. So it should be able to get the events. So that's where I would place it. This does not specifically separate it out. It's at the workspace where the events come in, all the information is kept there.
So you do this impact and dependency analysis in the workspace wrapper? It seems more like it should be on the server.
I'm not doing it as server because it's doing cross impact analysis. Every workspace is responsible for its own impact. So each client keeps its cache because it knows best what has the changes. And as API changes come in, it calculates it and sends out an event to itself and then to the other person. So the server is mainly just an event database. It keeps a record for archival process
I see.
and reconnecting.
Another thing with dependencies, you have this tool, but is it possible to specify dependencies manually in addition to that? And I think they should be managed on the server and distributed to all workspaces. Because, for example, I have a code that uses include file. That's everything that the tool can detect. But then I have the registry and configuration file mentioned, and when that configuration file changes, every application might break.
That's
And
right.
specifying this dependency is quite difficult.
Because that has to be manually done because the tool won't understand.
And the thing is, it should not be in the workspace, but in the server, because only, let's say, the implementer of the tool can know the dependencies, and
Right.
everyone should be aware of them anyway.
That's how to think about it. Or they could find out the problem and let others know, and in their dependency cache, they have that, but it'll be harder to change. So
The thing is, if it's not an automatic process to distribute this knowledge, somebody will forget it.
that's true.
That's one of the big problems. And the other thing is, you have often the analyzers on the syntactical level, like an API changes the signature. But but wouldn't it be a good thing to inform others of semantic changes that might not be signature changes but behavior changes? And the thing is, that is a thing that most automatic tools can't detect.
That's true.
Unless you have something like SpecSharp or ESC, if you have contracts on your code, then you can actually express semantic behavior.
And how many people might update that? The big problem is,
It depends.
often it's done incorrectly or incomplete.
If you're using SpecSharp, you cannot do it incompletely or incorrectly. It'll enforce you to do it correctly. When you compile, it'll actually check that what you're saying is true.
But even those descriptions are always partial. You're always partially describing the program behavior.
Are you documenting every return code, every failure case? Most
I
likely,
talk to Rooster, would, or real world people who
I'm
are
talking
slacking.
real world.
Yeah.
The thing is, if you have a tool that requires more specs to define the contract than to implement the functionality, it will not be used. The thing is, if you're talking research, or are we talking real world?
Well, yeah, it'd be a question for the SpecSharp team, for example, in MSR. If what you're saying is true, then they're wasting your time.
The thing is, it might help, but in the end, it's never a complete
So
specification.
it's finally going to be up to the developers, right? The whole idea with awareness is the individual has to give in some effort extra so that it benefits the entire group or that particular individual at the end.
Yeah, but also
So-
you need to have the infrastructure. If I decide to tell someone about my semantic changes, like using SpecSharp, then this has to be distributed on everyone. And the thing is, I put in the extra effort, there's a seed, another one doesn't do it, and suddenly your model breaks. Because suddenly somebody introduces a change that doesn't look like much, but in reality he changed something, he just didn't spec it correctly. And that's where real world and research collide.
So this is an interesting discussion, but let's thank Anita one more time, and then we'll take the rest offline.
Okay, thank you. Thanks for having me.